Let's say we take two charges, one is positive and another one is negative. So these two are different charges in nature. One is being positive, another one is negative. They are opposite charges or unlike charges. So if you bring these two charges close to each other, they will attract. And if you take two like charges, whether negative or positive and positive, they will repel each other. So whether they are attracting here or they are repelling here, it shows that the charges are applying force on each other. So we can say that the charges apply force on each other. So can we calculate the force between two charges? Yes, we can calculate the force between two charges by using Coulomb's law. Coulomb's law. So let's take two charges, one positive in nature, another one negative in nature. And the distance between two charges from their center is r. This r is the distance between the two charges from their center. And the quantity of charge on this positive one is q1 and the negative one is q2. So the force which is acting between the two charges, which is attractive in nature, you already know because they both are opposite charges. So the force which is acting on these two charges is directly proportional to the product of the two charges, and the force is inversely proportional to the square of distance between these two charges. Now if you combine these two relations, you will get a relation something like this. F is proportional to q1 q2 by r square. Now if we write this relation in form of equation, then we will get an equation something like this. So we can write k q1 q2 by r square. Here this constant k is equal to 9 into 10 power 9 Newton meter square Coulomb power minus 2. So let's solve a question related to Coulomb's law. So imagine there are two charges, same nature, positive and positive, and the magnitude of the charge on each is 2 microcoulomb, and here Q2 is equal to 4 microcoulomb. In between, I'm keeping a charge at point P. This charge has a magnitude of, let's say, 2 microcoulomb as well. The distance between the two charges is 4 centimeter, and the distance of point P from this Q1 charge is 1 centimeter. So we have to calculate what is the force on the charge at point P. Just for clarity, let's say the nature of charge is positive at point P. So we can apply Coulomb's law to solve this question. So we can use F is equal to K. Q1 Q2 by R square. So what I will do is I will solve this question into three steps. First, I will calculate the force acting between Q1 and the charge at point P. Then Q2 and the charge at point P. And then I will calculate the resultant force. So first, let's start with Q1, Q1 and P. So the force between Q1 and P could be calculated using K Q1 Q2 by R square, which is Coulomb's law. So we can write here K Q1 is 2 microcoulomb. So 2 into 10 power minus 6, micro represents minus 6, into 2 into 10 power minus 6 divided by our distance is 1 centimeter. It means 1 into 10 power minus 2 meter. So I have converted it. The next step is substituting the value of K here. If you calculate these things, so simply you will get 2 into 2 4, and 10 power minus 6, 10 power minus 6 will give you 10 power minus 12, and this thing divided by 1 will not cancel anything. So we can get here, first of all, let me substitute the value of K. K is 10 power 9 into 10 power 9 Newton meter square per Coulomb square. So 9 into 10 power 9 into 4 into 10 power minus 12 divided by 1 into 10 power minus 2. So 10 power minus 2 from here, if it goes up, it becomes plus 2. So finally it will cancel and we will get F Q1P is equal to 9 into 10 power 9 into 4 into 10 power minus 10, because 10 power minus 2, when it will go up, it will cancel just 10 power minus 2. So it will be the quantity which would be left is 10 power minus 10. So when we will further simplify this quantity, we will get 9 4 ja 36, 36 into 10 power minus 1, and this 10 power minus 1 Newton. It means we will get a force of 3.6 Newton. Now the second step, I will solve it on the next slide. Second step is to calculate the force between Q2 and P. Q2 is 4 microcoulomb. Here we can see Q2 is 4 microcoulomb. Q1 is 2 microcoulomb. And the distance between Q1 and Q2 is now 3 microcoulomb. 3 centimeter. So we can write this here. F Q2P is equal to K, again same formula, Q1 Q2 by R square, and we can write here 9 into 10 power 9 into 2 microcoulomb, it means 10 power minus 6, into 4 into 10 power minus 6 divided by 3 into 10 power minus 2, because I'm converting centimeter, which is 3 centimeter, into meter, so I need to add 10 power minus 2. So what I will get here, FQ2P is equal to 9 multiplied by 2, we will get 18, and 18 4 ja, we can get here 72. So 72 into 10 power 9 into 10 power minus 12, like the last step, divided by 3 into 10 power minus 2. So 10 power 2, again it goes up, it will cancel just minus 2. So 10 power minus 10 would be left here, and we can write F Q2P is equal to, now we have to divide 72 by 3, so we should get how much? 2.4. No, not 2.4. I'm doing something wrong here. We will not get 2.4. We should get 3 2 just 6, then 3 7 ja 21, and 3 3 ja 9, so 3333. I will just write 27.3 into 10 power 9, 10 power minus 10, and this will be left just with minus 1, and it's in Newton. So I can write F Q2P is equal to 2.73 Newton, right? Because this 10 power minus 1 will shift the decimal towards the left side. Now, if I go back to the diagram once again, and let me change the color of the ink so that I can draw it here. Both forces are just opposite to each other, because Q1 is also positive, Q2 is also positive. And another thing, they both are applying force on this charge at point P, and that charge is also positive. It means, first of all, Q1 and this charge at point P, they will repel each other. It means this is F1 FQ1P, and the force acting on this charge at point P due to charge Q2 would be something like this: FQ2 FQ2P. Now what you can see is they both are opposite in nature. Yeah, one may be larger in magnitude, another one may be smaller, and that we will see here. So FQ1P is 3.6 Newton and FQ2P is 2.73 Newton. So we can write F net would be is equal to FQ1P minus FQ2P, which would be F net is equal to FQ1P is 3.6 Newton, yeah, 3.6 minus 2.73, which will give us how much? We will get here, if we subtract it, we will get 7, then 15 minus 7 will give us 8. So 8, it means 0.87 Newton of force. But the larger force is F1P. And if we go to the diagram once again, it means the force acting at point P on the charge of 2 microcoulomb would be towards the right side, because this FQ1P is pointing towards the right side. So 0.87 Newton of force towards right side. Now let's go to the next question, and I will leave it as a homework for you. So imagine there is an equilateral triangle, and let me take shapes. I can draw a better diagram using shapes. So if I take a shape here, something like this, is it looking like a triangle? Yeah, sorry, equilateral triangle. I think so. So here, let's imagine there are charges. One is here and another one is here. This one is 20 microcoulomb and this one is also 20 microcoulomb. And here we have kept one charge of 1 microcoulomb. So this is point B and this is point C, and let's give it a name, point A. Point A. So what we need to do is we have to calculate the force acting on 1 coulomb of charge which is kept at point A because of the charge at B and C. So what we need to calculate? We need to calculate force at A due to B and C. So calculate magnitude and direction of force due to at point A due to B and C.